the fascinating field of photovoltaics, generating power with sand and the sun. Capturing solar energy is the end result of complex chemical and physical processes. As a first step, raw silicon is extracted from quartz sand. For use in the photovoltaics industry, the semi-metal must be 99.99% pure. To generate solar power, the photovoltaics industry utilizes the semiconducting properties of silicon. In special ovens, raw silicon is melted at temperatures of over 1,400 degrees centigrade. A thin rod, known as the seed crystal, is then submerged into the liquid raw silicon and pulled back up very slowly. At this step in the process, the liquid silicon accumulates on the seed crystal and solidifies. Over 4 days, a silicon rod of up to 2.8 meters length takes shape. This basic round crystal, known as an ingot, is now cut into a rectangular shape. This is done for purely practical reasons. Later on, square-shaped solar cells can be installed much more effectively on the surface of a solar module. The ingots are cut into millimeter-thin slices using a very fine wire saw. The individual slices are called wafers and form the basis of each solar cell. Once the wafers have been cut, they are sent through a wash tunnel. This is because even the smallest piece of dust or dirt can compromise solar cell production. The wafer's surface is now very flat. Just like a mirror, many rays of light are reflected and can no longer be used to generate power. To prevent this reflection, the surface is etched and roughened in a chemical bath. If the cells are put under a microscope, one can see the resulting pyramid structure. With this fine pyramid structure, light is refracted multiple times, allowing incoming light to be used far more effectively. The next step in solar cell production is diffusion. Here, a negatively charged phosphorus layer is added to each wafer's positively charged layer. In an oven heated to some 900 degrees centigrade, phosphorus atoms are injected with the help of nitrogen. The gaseous phosphorus-nitrogen mix is deposited on the wafer. At the interface between positive and negative charge layers, the free charge carriers created by the light are released. This generates an electric current. But how is the power that is generated in the individual cells transported? A stamp presses a silver alloy onto the front of the cells. This creates the typical grid pattern. This silver coating ensures that the power can be transported later on. The solar cells are now complete. They can generate and transfer power. But each cell has a different level of electrical conductivity. In a series of tests, the cell's conductivity is evaluated and sorted. Following the test phase, the solar cells are assembled. The cells are soldered together in such a way that the voltage accumulates. In a process referred to as lamination, the cells are assembled behind a pane of glass. As a result, they are protected from the elements for more than 25 years. One solar module contains 60 cells. When a number of modules are connected to one another, a solar power plant is created. And power is generated from the sun and the sand.